Hello, this is the 6th newsletter. I will show you the machine learning course with hands-on coding tutorials that I recommend you to take. Then we'll look at the upcoming EAGE events that have something to do with machine learning. On the scientific side, I will show you our pick for the paper in this month. I will also talk about Jan's first blog series on normalizing flows. This newsletter is full of exciting information. If you don't know me, my name is Ruslan, and I'm here to teach you machine learning in oil and gas. It seems like yesterday we started this newsletter with EAGE to help the larger geoscience community. But we are already on the 6th edition. Of course, it's not a big deal. But since this is unpaid work, we have to be proud of every little steps we take along the way. Thank you all. And now let's get to the content. The first one is the course that we already seen. I would say we've seen that course a lot because it came out in 2012. I'm talking about Andrew Ng's machine learning course. But this time we have an update to it. This free course Specialization will teach you the key ML concept and the practical skills you need to apply AI techniques to real problems. So expect to learn more than just about MNIST and fetching dataset. It gives an overview of modern machine learning, including supervised, unsupervised, and some of the best practices used in Silicon Valley for machine learning. If you are like me, you're probably already taking this course. You might be wondering what is the difference and what was the update about. If we put it against original machine learning course, the new version has a longer list of topics on deep learning algorithms and tools that are used today. As usual, Python programming language is used to make assignments and follow lectures. And I think the most interesting part is the section on practical advice, which has best advices from the last 10 years. And I actually would say more than that. Before starting work projects, I want every new member in my data science team to take this course. Even so, I only hire people who have a lot of experience. This course helps everyone on a team agree on how to talk to each other. Now, I'd like to give you an updated list of the upcoming EAGE courses you should think about taking. It starts in 1950s and goes to the AI revolution in 2010s. It is a review of AI business side and the basics of ML. The practical goal of this course is to teach you everything you need to know about deep learning and how it works. Also, compare deep learning to the traditional neural networks, which had been used in the industry for 30 years. This workshop brings together experts to talk about state-of-the-art applications used in the upstream industry, which includes exploration, drilling, and production. You will take a part in talks about expected machine learning applications that are made possible by more powerful computers. People say that September, one of the best times to visit Milan. And this course will teach you how machine learning is used to make predictions about fluids and lithology. The lectures and exercises focus on preconditioning the data and classifying the data using different methods. And now we are transitioning to research part. And the first one is recommendation for the paper Seismic impedance inversion based on cycle consistent generative adversarial neural network. You probably already know that seismic impedance inversion can be used for reliable forecasting of reservoir properties and that it also can help us figure out stratigraphic interpretation. But it can be hard to calculate impedance. AI-based data-driven approaches have shown potential, but they are hard to use because there isn't enough labeled data. After all, drilling costs are high, and it's really hard to get well logging parameters. In this study, the authors proposed a method for seismic impedance inversion that uses a generative adversarial neural network, and it works well, even when a small labeled data available. They tested on real and synthetic dataset and shows that the suggested method can usually do better than the competing methods. In the description you can find the link to the full video and the paper. We have finally reached the best part, the blog by Jan. This is the first in a series of blogs that will explain what a normalizing floor is, how it works, and how it can be used in our industry. Normalizing flows are one way that data can be used to make a generative models. To make it easier to understand, let's look at the bigger picture and talk about the most commonly used neural networks. They are called discriminative models, and their only job is to guess which predefined type a new piece of data fits into. And we have to be honest, they are very good at this. Keeping in mind that discriminative models don't look at how data is structured, instead they just find enough clues to help them divide the data into the classes. In other words, they spend a lot of time and effort modeling the boundary between the classes that separates positives from negatives. On the other hand, generative models don't try to find an artificial line between the classes. Instead, they try to build a model of each class. By model, I mean a way of describing the whole distribution. Generative models can also be used for classification and/or regression after it has been trained. Some application of generative models in oil and gas you can find on this channel. It was used for acoustic impedance and velocity inversions, seismic image imprinting, denoising, and many more. And the normalizing floor. Don't forget to like this video and check out our other newsletters where you might find something interesting and useful there. Thank you all, and see you at the next one.